Right. You remember that I welcome you back. First of all, let me welcome you back. And you remember that we started from here. This is the question we are solving before we are timed out. And it says that the following data represents number of sample of number of home fires started by candle in the past several years. Okay. So it says the question wants us to estimate the 99% confidence interval for the mean number of home fires started by candles. And because how many years we are choosing? 1, 2, 3, 4, 5, 6, 7 years. The N is 7. The sample mean we estimated it using Excel. If you remember, we use Excel to calculate the sample mean, and then we use Excel for the sample standard deviation. And it says with 99% confidence. That means our alpha is 0.01. We find our degree of freedom to be n-1, which is 7 minus 1, minus 6. We also find our critical value from the table. Where we are is the error margin. That's when we are timed out. So we were able to estimate it before we were timed out. And I'm going to pull it from where we have it. It's from here. So I'm going to copy it and then paste it there so that we can complete the question. Okay. Once you have the error margin, basically you have estimated your confidence interval, because when you have your error margin, all you have to do next is to subtract it on the left side and add it on the right side, and you get your confidence interval. So let's do it so that the 99% confidence interval now becomes 99%. Okay. The 99% confidence interval is given by this formula. I think I wrote it down somewhere. It's right here. Okay, I'm going to copy it. S bar minus error, where S bar represents the sample mean. See? Which is S bar is here is 7041.43. So we have 7041.43 minus error. Let me make it a little bit bigger than what it is here. Okay. Minus error. I know error is 2256.17 is less than the mean. Okay. It's less than the mean. Give me 1 minute there. Okay, less than the mean. Okay, and less than because the mean is what you are trying to estimate. Then repeat the same process, but this time around, use the plus sign, not the minus sign. So on the right side, use the plus sign and not the minus sign. Okay. So I have you have all my participants here. Who am I missing? Okay. All this together. Now, using our calculator, we can get this the answer for this. I'm going to write it down so we can go to our calculator. Write it down. Okay. Got 7041.43 minus 2256.17. Make sure I have 7041 again. So I'm going to take you to the calculator so you can calculate this. Where is my calculator? That is somewhere. Yeah, I'll find it. It disappeared. Okay. Now I found it. So I have 7041.43 minus 2256.17. It gave me 4785.26. Okay, so let's go and put it in. And the left side, so we have 4785.26. Okay, it's less than the mean. It's less than. Then on the right side, we add it. So I'm going to go there and put addition instead. So to add this, 9297.6. 9297.6. We're going to put 9297.60. So that is our confidence interval. So we can now conclusion now become, okay, we can say with 95% confidence. Well, that one is, it was asking us for 99%. So let's say with 99% confidence that between, excuse me, 4,785, that okay, let's look at the question. That's the best way to find it. See, find 9% confidence interval for the mean number of home fires. Okay. Because that on average, that we can say with 99% confidence that on average between, okay, 4,785 to 9,297 has home fires. Home fires are started by candles. See? So we can say with 99% confidence that on average, yeah. So that on average, come on here, on average, between 4,785 approximately to 9,207 home fires are started by candles. Any question on this? Any question?
Average and mean means the same thing, right?
Yeah, yeah. And that is the average we're trying to, that's the average right here. That's what we are trying to estimate. We're using the sample to estimate the population mean, you know. That's the whole thing we are doing here for confidence. Any other question? Good. So we have done the confidence interval for the mean. Now let us look at the confidence interval for proportion. Now I'm going to move this down so we have enough room for this. The confidence interval for proportion. Now, when we say proportion, we're referring to percentages. A part of something is a proportion. Okay, a part of something. So Okay, I think I made this bigger too much. Okay. Now, proportion is like I say, we are referring to percentages when we are say proportion. So when we say confidence in terms of proportion, a proportion represents a part of a whole. So, for example, a USA Today Snapshot feature stated that 12% of the pleasure boats in America were named Serenity. See, 12% out of 100% is a, so it's a part of the whole components of whatever we are trying to estimate. So we use P for population proportion, and we use P hat for sample proportion. So we are trying to use the sample proportion to estimate the population proportion. The same way we are trying to use the sample mean to estimate the population mean when we are doing confidence interval for the mean. Now, sometimes the population proportion will be given. Oh, sorry, the sample proportion will be given. But if it is not given, you can estimate it using this formula. P hat is X over N. So S is the part of they will give you two numbers. One of them will be X. S will be part of the N, So then Q is always 1 minus P hat. Then our error for proportion, the error formula is a little bit different. The same principle, but this different formula. Principle is that you estimate the error using the critical value that you have and then plug it into the formula. Then the confidence interval is written as, since we are trying to estimate the proportion, it will not be X bar here, it's going to be P hat minus error, less than P hat plus error. So let's try this one, some P. Okay. It says, in a random sample of 200 investment advisors, 70 recommended information technology stocks. The question says, give the maximum error with maximum error of estimates, okay, with 95% confidence. Then construct a 95% confidence interval from true proportion. Solution. Okay. Now, first of all, let's look at our P hat. Our N, our X, it says here that out of these 200 investment advisors, 70 recommended IT. So Series S is 70 as part of the N. Okay. Then P hat, sorry, I mean to say N, P hat. N equals out of 200. Okay. So this is small N, that is small N. So now let's find our P hat. P hat will be, remember, is X over N, which is 70 divided by 70 divided by 200. So I'm going to put it in a place where it will allow us to use P hat. So I'm going to take you there. Okay. P hat. P hat. Okay. P hat equals X over N. X over N, which means 70 over 200. 70 by 200 equals, we can get this from the calculator, 70 divided by 200. 0.35. 0.35. 0.35. Okay. I'm going to copy it and take you to the main workbook so we can paste it here. Okay. Then next thing, we need to get our Q hat. Remember, the Q hat is 1 minus P hat. So Q hat will be 1 minus P hat. Q hat equals 1 minus P hat. P hat equals 1 minus 0.35. I think that's what we got. I think we got 0.35 for P hat. Yes, 0.35. So 1 minus 0.35. 1 minus 0.35. 0.65. 0.65. 0.65. So I'm going to copy it. Okay. I'll go there and paste it. Memo book. Now, part A says, give the maximum error of estimate. Now, we can now start doing part A. This one, what we just got is the basic thing we need to get. Then start part A. The formula for error is right here. Error Z alpha over 2 times standard square root of P hat times Q hat of N. But we need to get this Z alpha over 2. I told you from the from when we were doing confidence interval that if it is given, you can pick it from the table. But if it's not given, you can estimate it. So we don't have it here, and we can pick it from the table. Let me write it down first. Z alpha over 2. Okay, let me show you in this. Z alpha over 2. Alpha over 2 equals, since we don't have it here, I will check it. If it's not in the table, we use P over 200 to estimate it. Okay. Now, it says 95% confidence. So I'm going to do 95 over 200. I explained this in the class. Okay. 95 over 200. If it's not given, if it's given, you can just pick it from where it is written. 95 over 200. That would be 0.475. 0.475. 0.4750. Then go to the table of normal distribution and look for this. Okay, I'll take you to that table of normal distribution. 0.4750 right here. Sorry. 0.4750. See, normal distribution. See, table of normal. See, 0.4750. 47. You can see right here. 4750 right here. Yeah, can make this a little bit. See, 4750 is right here. If you follow it to the left, 1.9. Okay, if you follow it up, 1.96. 1.96. So our critical value is 1.96. Alternatively, let me show you what you can do if this number, if I did this because it wasn't given here. So I'm using it to show you how you can get it if it is not the value of Z alpha over 2 is not given. Otherwise, if you can pick it from the table as well, you can pick it from here. If you go all the way down, some places you can see where it is given, like here. You can see for 95, you can see 1.96 right there. So you can pick it from here. But sometimes they will not be given. So in that case, you need to know how to estimate it if it's not given. That's why I showed you how to estimate it. Now with this, we can answer part A. Part A says give the maximum error with 95% confidence. So maximum error is this. It's Z alpha over 2 times square root of P hat times Q hat over N. Let me write this down. error is z alpha over 2 times square root of p hat times q hat over n. And we have our p hat here as 0.35, 0.35, and our q hat as 0.65, and z alpha over 2 as 1.96. Consider here 1.96. So, and our n, how many of them? N is 200. N is 200. So we can just estimate it. So the maximum error. Okay, maximum error E is given by this formula. So I'm going to take you to the page where we can get the formula and use it. Becomes error equals z alpha over 2. Okay. Z alpha over 2. Okay. Times square root of square root right here. Okay, we have our p hat, which is from here. P hat is p times q hat. Okay, over n. Okay. Oh, excuse me. Which is square root of our z alpha over 2, we got it as 1.96 times square root of, okay, our p hat is 0.35 times our q hat is 0.65 and n is 200. Okay, let me put it on this formula. Square root of 0.35 times 0.65 over 200. So we can, once we get the answer, we can put it, there. So you have 1.96 times square root of, okay, 0.35 times 0.65 over 200. Excuse me, 200. I got 0.066. 0.066. Okay. 0.066. Now we can go and put it in and then, transfer it there. 0.066. I'm going to copy this. So we answered part A of that question. Part A of that question is not answered. And once we answer this part A, we are almost done with the question. Question now says, construct a 95% confidence interval for the mean. So we already have the error margin. So finding the 95% confidence interval is easy because the best is to have the error. So the 95% confidence interval is given by this formula. The is given by this formula here. I'm going to write the formula so that you can see the formula from here. Right here, P hat minus error is less than P hat plus error. Matter of fact, I'm up here. P hat minus error. Then P hat. So our P hat, remember, is 0.35, which means 0.35 minus error. Our error is 0.066. Okay, it's less than P, which is the population proportion we are trying to estimate. It's less than P hat plus error, which is 0.35 plus error 0.066. Let me make it bigger so you can see it more clearly. Make it 16. So once you figure this out, now we get our confidence interval. So let me write this down. 0.35 minus 0.066. Okay. So we go 0.35, 0.35 minus, oh, excuse me, 35 minus 0.066, 0.284. 0.284. Okay, 0.284. Okay, I'm going to copy this. Less than P, because the P is this time around is meeting the proportion. So less than, then let's use B to add them together. So I'll take you there so you can add changes to plus and see what the outcome will be. Plus 0.416. Yeah, 0.416. So that is the proportion we are trying to estimate. So that is 95% confidence interval for the proportion. So conclusion. So you can see this is for number, say in a random sample of 200 investment advisors, 70 recommended IT stocks. So construct 95% confidence interval. So we can say we are 95% confident. We are 95% confident that between, this is 0.284, I mean it's 28.4%. Okay. To between 28.4% to between 28.4%, okay, to have 0.4160 to 41.6% of all investment advisors, of all investment advisors recommended IT stocks. That is our conclusion. Questions?
No.
So now we have a very short time. We're gonna log back in one more time so we can finish this. We don't have much left. but 8 minutes will not be enough for us to finish it. So I'm going to time us out. So wait for 10 minutes, log back again. Let's finish up. Okay. So that next week we'll begin a new test of hypothesis. So when we come back, we'll be working on a situation where they give you the percentage. Remember this one here. They didn't give us.
Professor, you're
Yes,
gonna upload this. You're gonna upload this recording as well.
Oh, you want the recording?
Yeah, I said, are you saving this one? Are you gonna upload it?
Yeah, I mean, if you want me to, yeah, sure. Are you talking about the recording or the handout?
No, I'm saying a recording of this Zoom.
Or the video, right?
Yeah, are you saving it?
Yeah, sure. I'm gonna upload it for you.
Okay.
So now, we still have time for questions. Any other question before we are timed out? You can be thinking about it. See, this one here, they said 70 out of 200 investment advisors. But in some questions, they won't tell you that. Like here, if you look at this one, he said a survey of 200,000 boats owners found that 12% of the pleasure boats were named Serenity. So they won't give you this out of this, instead they'll give you the proportion. It's exactly 12%. So how do you solve that kind of question? That's what we'll be looking at into when we come back next. Then after that, we can now solve one question here about minimum sample size. And then I can then put your classwork for you. And then we'll be like, so we'll come back. We won't spend much time. We're not going to waste time on that. Okay. So
okay.
Yeah. So since nobody's asking any more questions, let me to make it faster. Let me time us out because I have only 6 minutes. Then wait for 10 minutes, log back in, and let's round up. Okay. I see you back here in 10 minutes.
Okay.
Okay.
Okay.